Hello students. In the last video we showed you how to use trigonometry to find unknown side lengths in a right angled triangle. And in this video we're going to show you how to find unknown angles. Before we do that, we need a quick review of inverse operations. So looking at this equation here on the left, we've got some unknown number. We added 5 to it and the answer is 8. So the way you learned how to find the value of y algebraically was to say, well, we've got to undo adding 5, which is taking 5. And that's the reason for that, of course, adding 5, taking 5 is just the same as adding 0, which doesn't change the value of things, and y equals 3. Similarly, the opposite of the square root of a number, so I got the square root of y is 4.5. And to undo the square root, I have to square both sides. Squaring and square root are inverse operations, so they cancel out, and y equals 4.5 squared, which we all know, or maybe you don't know, but I do. It's 20.25. So we're going to basically use the idea of inverse operations to find unknown angles. Okay, so we can use our calculator to find the value of sine of 38. We've learned how to do that. So let's just go ahead and do that question. So we just click on the sine button, type in the angle, and press equals. And round it off to say 2 decimal places, we get 0.62. So that's finding the sine. Now to find the angle, we end up with a question like this. What if we know that the sine of some angle is 0.4067, and we need to figure out what the angle is? So here's what we know, and here's what we're trying to find. Well, basically what we have to do is we've got to do the inverse of finding the sine. And believe it or not, the inverse of finding the sine, that operation is called inverse sine. So we need to do inverse sine on theta. So we need to do this, inverse sine. Now here's how we write inverse sine. It looks a bit weird. Sine to the negative 1 of 0.4067. So that's just saying we've got to undo taking the sine, and that'll get us back to the angle. Now where do we find the inverse sine operation? Well, it's actually not too hard. If you look at your sine button on your calculator, I'll just clear everything. Above it, written in gold on my calculator, is the inverse sine. Sine to the negative 1, we also say sometimes. So all I have to do to find the angle is hit the shift key, the sine button. That gives me the inverse sine. I type in the value of the sine, 4067, and press equals. I'm going to do this to the nearest degree, and looks like that's going to be 24 degrees. So the angle whose sine is 0.4067 is 24 degrees. So that's pretty easy. Basically, to find the angle, don't use the sine button, use the inverse sine button, or of course you might have to use the inverse cosine button. Look on your calculator. Above the sine is inverse sine, above the cosine button is the inverse cosine, and above the tangent button is inverse tangent. So in each case, to find the angle, just press the shift key first. Okay, I'll do the one on the left, then you're going to do the one on the right. Okay, so I'm going to start like I start every single question in trigonometry by identifying opposite adjacent hypotenuse. So opposite the right angle is the hypotenuse, opposite the angle we know, that's the opposite side, and the angle next to it is the adjacent side. So the two sides that I know are the adjacent and the hypotenuse, and that tells me that I need to use the cosine. So start, as we always do, by saying cosine of the angle equals adjacent over hypotenuse. Let's put in everything that we know. Well, we don't know theta yet. That's what we're trying to find. The adjacent is 21 on 28. Now, because we're going to be typing this into a calculator very shortly, we actually don't have to simplify that or even turn it into a decimal. Okay, now here's the new step. I'm trying to find theta, so I'm going to write theta equals, and to do that we have to take the inverse of the cosine, and I just leave it all nicely as a fraction. Because I'm using the calculator, there's no need to turn it into anything nicer. And now I'm just going to type that straight in. So here we go. Okay, I'll clear what I have. So I need the inverse cosine. So shift cos. I'll use the fraction button. 21. Just so it looks exactly like what I've written down. Okay, double check. Inverse cos of 21 on 28. That looks pretty good. And to the nearest degree, 41 degrees. So finding missing angles is pretty straightforward. Okie doke, stop the video, go ahead and do the question on the right, and once you finished it, come back and we'll check your answer. Okay, welcome back, students. Okay, once again, we'll start as usual by identifying the hypotenuse, the opposite side. Let's get rid of that little dot. The opposite side and the adjacent side. Now the two sides that I know are the opposite and the adjacent. So that means I've got to use the tangent ratio to solve this particular question. So the tangent is the opposite over the adjacent. We we write in everything that we know. The opposite side is 16. The adjacent side is 19. Now we need to do the inverse operation to get the theta by itself, which again is called, not too surprisingly, inverse tangent. 16, whoops, might help if I didn't make any mistakes like that. 16 over 19. And we now need our calculator. Clear inverse tangent. 16 over 19. Okay, just have a quick look. Yep, it looks like it's all typed in correctly. And to the nearest degree, that's 40 degrees. So that's all there is to finding unknown angles in a right-angled triangle. Okay, what I'd like you to do here, read the question carefully. If need be, well, you can't really underline because you're looking at it on a screen, but mentally underline the information. Draw the diagram. That's the important part of this question here, and see if you can answer the question. So stop the video. Once you've got an answer, start it up again, and we'll check your answer. Okay, welcome back, students. Okay, a helium-filled balloon is attached to the ground by a 24.5 meter string. A light breeze is blowing so that the base of the balloon is at a height of 22.6 meters above the ground. So the idea is we've got the ground there. I'm standing there, and the balloon is being blown by the breeze. I'm assuming the string is straight, not totally accurate, but sometimes in mathematics we do models that aren't perfectly accurate to start with. So there's the string, there's the balloon, and we need to know the straight down distance, 90 degrees. That's what that 22.6 represents, is the distance above the ground directly. So it's 22.6 meters above the ground. And the length of the string is 24.5 meters. And there's our right angle triangle. In fact, I'll even go ahead and get rid of the extra bits. So the mathematical diagram, we only have in there what we need. Okay, now we can go ahead and find the angle. So it's saying which of these two angles do we want to use? There's actually two angles here. If I extended the ground, there's that one and that one. And of course, the one we're interested in is that one, the angle that it makes with the ground and the string, the smaller angle. Okay, let's go ahead and do the question. So there's the angle that we're looking for. That's the opposite side. That's the hypotenuse. That's the adjacent. So we know the opposite and the hypotenuse. Oops, I don't have a SOHCAHTOA here, but we know, hopefully we know by now, that sine is opposite over hypotenuse. So we write the formula. Substitute, put in everything that we know. The opposite is 22.6. The hypotenuse is 24.5. Now we've got to find out what theta is, so we need to take the inverse of the sine function, which is inverse sine. 22.6 over 24.5. By the way, this gives you a good example as to why you're better off leaving these as fractions. If you decided to turn that into a decimal, unless you're willing to write down all those decimal places, you're going to end up with an answer that's slightly inaccurate. So because this is so easy to do, keep it all in there. Therefore, you're working with the exact data, and you're only going to have the calculator round off the answer at the very last step. Excuse me. Okay, let's go ahead and work out the answer. So we need shift and sine, fraction, oops, that's a mistake, fraction 22.6 over 24.5. Double check that we've typed it in correctly. Looks pretty good to me. We're going to round it off to the nearest degree. 67.28, so that's going to be 67 degrees. So the diagram isn't particularly accurate, but that doesn't really matter. Okie doke. So there's how we find unknown angles using trigonometry. Now head off to your textbook and do the questions in the textbook to cement this idea in. Thanks very much.